So in this lab, we were able to use Hooke's law to determine the spring constant, which is K. And during our analysis, after we collected our data by putting some different masses on a spring and having the force pull down on it, we were able to calculate, or measure the displacement that the spring caused when it was weighed down by the masses. So going to our graph, we plotted force over displacement. Force we got by multiplying 9.8 times our mass. So we had, for the first one, we had a mass of 0.1. We started with 0, but then for the first one we had a mass of 0.1, which you got 0.98, which is right here. Then 1.96, 2.94, and then 3.92. And then we plotted that against our displacement, which we had as 0.015 meters, 0.05 meters, 0.085, and then finally 0.125. So after we plotted all those points, we drew a line of best fit, and we were then able to calculate the slope of the line of best fit. So your change in y here is 3 minus 1.75, which gives us 1.25. And then our change in x values was 0.095 minus 0.055 for a 0.04 change in x. So down here, since slope is the change in y over change in x, we have 1.25 newtons, because that's the unit of force, over 0.04 meters, which is the unit for displacement. And we were able to get a number of 31.25 newton over meters. That is the number of the K value, the spring constant, which basically tells us how stiff the spring is, and how much elasticity it has. So since we had an accepted value of 30 newton meters, it's easy to say that this is pretty close. So the lab was a success. Down here I calculated my percent error. So we took 31.25 minus 30 over 30 times 100, and I got only 4.1% error. So like I said before, I consider that a success, and the lab worked like it was supposed to. So possible sources of error, I think one of the main issues was that perhaps we rounded when we read our displacement, when maybe it was actually a little more accurate. Also, perhaps the position of the masses and the, I guess, orientation that we hooked them onto the spring could have perhaps changed the displacement a little bit of the spring. But overall, I think we were still able to see how spring constants work. And I know we haven't watched the video on Hooke's law yet, but I'm sure this is a good introduction. So yeah.